Okay, example 3-4 is about the relationship between delta Z max and Froude number in triangular channels. So if we have a triangular cross sections like this with a sidewall slope of 1 vertical to m horizontal and a water level up to here, so we have depth y and then the top surface T is equal to 2my and area is my square. So we want to find the relationship between delta Z max and Froude number in section 1. So we want to know how we can develop this relationship. So using energy equation, so E1 is equal to E minimum plus delta Z max. And I can rearrange this relationship to write it based on delta Z max, which is E1 minus E minimum. And then I divide the left and right hand side by Y1. So the left hand side is exactly the same as what we have. Now we work on the right hand side. The first term is E1 divided by Y1. Okay, so E1 is Y1 plus Q squared divided by 2G A1 squared. So I divide that by Y1. And then here we have Y1. Now I can also write the relationship between Froude number in section 1. So F1 squared is equal to Q squared T divided by G A1 to the power of 3. And then if I rearrange that based on discharge, so I'm going to have Q squared is equal to F1 squared G A to the power of 3 divided by T1. So I can use this relationship here to convert discharge into Froude number in section 1. So if I replace that expression to here, then I will have E1 divided by Y1 is equal to, so Y1 divided by Y1 is equal to 1 plus, instead of Q squared, I put Froude square G A to the power of 3 divided by T1. And then what I have in denominator is 2G A1 square. Okay, so here I have G and G cancels out. A1 square and A1 to the power of 3 cancels out. So I have A1 and then here I have T1. So now I use the expression to identify cross-sectional area and top width. So 1 plus F1 square times My1 square divided by 2 times 2My1. And then remember we have E1 divided by Y1. So we have Y1 here too. Okay, so M and M cancels out, Y1 square and Y1 square cancels out. So what is left is 1 plus F1 square divided by 4. So you'll see that the first expression here is now formed 1 plus Froude square divided by 4. Now, the second term here is what we need to develop. So from previous example 3-3, we find out that a minimum is equal to 1.25 of YC, which is 5/4 YC. Okay, so here what we have is minus a minimum divided by Y1, which is equal to minus 5/4 YC divided by Y1. So if you look at equation 3.29 of the textbook, you'll find the relationship between YC and discharge. So YC is equal to the 5th root of 2Q squared divided by GM squared. So what we are going to do is we are going to use that expression. So it becomes minus 5/4 2Q squared divided by GM to the power of 2 to the power of 1/5 divided by Y1. So we use the same relationship as here to convert discharge into fruit number. Okay, so I'm going to use that. So it becomes minus 5/4. And then I'm going to also move Y1 here inside of 1/5 power. So it becomes Y1 to the power of 5. So here I have 2 times, and Q squared is F1 squared GA1 to the power of 3 divided by T1 times G times M squared times, now I have Y1 to the power of 5. And everything to the power of 1/5. So you see that I just brought the Y1 to the power of 5 here. Now I can simplify this a little bit. So G and G cancels out. And then I will put the expression for the values of area. So minus E minimum divided by Y1 is equal to minus 5/4 2 fruit 1 squared times MY1 squared to the power of 3 divided by 2MY times M squared times Y1 to the power of 5, and everything to the power of 1/2. Okay, so here MY1 to the power of 2 to the power of 3 gives me M to the power of 3 Y1 to the power of 6. So M to the power of 3 cancels out here, and then Y1 times Y1 to the power of 5 cancels out with Y1 to the power of 6, and 2 cancels out. So I have fruit squared to the power of 1/5, which becomes equal to minus 5/4 F1 to the power of 2/5 or 2/5. So you see that this is the second part of the expression. So if you put everything together, then we are going to have delta Z max divided by Y1 is equal to 1 plus fruit 1 squared divided by 4 minus 5/4 fruit 1 to the power of 2 over 5.